Hey guys, this is Mrs. Marquette, and on day 3 of our factor chapter notes, we're going to talk about multiplying polynomials. So when they tell us to find the product, we know that product means multiplication. So today we're going to talk about multiplying either 2 polynomials together or multiplying 3 polynomials together. The main thing that we're going to do is use the distributive property. So remember that this distributive property means I have to multiply what's in the first. I do 5 times 2 is equal to 10. 5 times 3 is equal to positive 15. And then I add it together for 25. We're going to be doing that same thing today. We're just going to have some x's and y's floating around in there. So let's look at the first example. Number 1 says x times x squared minus 2x minus 4. We remember that an x is really x to the first. So I'm going to use the distributive property to multiply my first polynomial, x to the first, times the second polynomial. So this is equal to x to the first times x squared, x to the first times negative 2x, and x to the first times negative 4. So I can see where my x to the first is in all 3 pieces. Now we have to think about our first lesson of the factor chapter, which says when you have 2 powers multiplied by each other, if they have the same base, like x and x, I can add their powers. So x to the first times x squared is x to the third. Then when I multiply that second piece, I have a 1 times a negative 2, which is negative 2. And then x to the first times x to the first is x squared. The last one, I have 1 times negative 4 is negative 4, and then x to the first. And that is my final answer. And even, I don't really need that power on my x if it's just x to the first. So that should be something that feels familiar. Number 2 says x plus 4 times x plus 3. So in the last one, we had to multiply the first polynomial by everything in the second polynomial. We're going to have the same thing here, but what we're going to do is we're first going to have our x multiplying to everything in the second polynomial. Then we're going to have the 4 multiplying to everything in the second polynomial. It's kind of like using the distributive property twice. So we'll go an x to the first times an x to the first, and remember we're multiplying, so each term we've got to multiply, and then plus x to the first times 3. That's the x multiplying to each piece. Then we do the 4. 4 times x. And then plus 4 times 3. I know that x to the first times x to the first is x squared. 1 times 3 is 3, so I have 3x. 4 times x is just 4x. And then 4 times 3 is 12. On this one, I notice that I actually have some like terms. So I look and I say, well, x squared doesn't have any other like terms. But 3x and 4x, I have 3 plus 4 is 7. That doesn't change the x's. It just tells me how many I have. And then plus 12 is my final answer. We have an acronym that can help us to remember to multiply each piece of the first binomial or polynomial by each piece in the second polynomial, and that is FOIL. FOIL stands for first. That's when we took our x times our x. It's the first in each of those 2 polynomials. And then O is for outside. That's when we multiplied our x times our 3, because those are on the outside of our 2 polynomials. So it's like the outer pieces. The I stands for inside. So that's when we multiplied our 4 times our x, because if you look at those 2 polynomials, it's on the inside. And L is for last. That's when we multiplied the 4 times the 3, because that's the last piece in each of the 2 polynomials. So if that helps you to remember that you have to multiply everything in the first by everything in the second polynomial, that works. Otherwise, if you want to draw those little arrows to make sure that you multiplied your x by each piece and your 4 by each piece, I just want you to find a method that works for you. So let's do another one of those. we have 4x squared times x minus 4. On this one, I just have the 4x squared on the outside, so I can distribute it in, use the distributive property. So I have 4x squared times x to the first plus 4x squared times negative 4. If you don't need to do that middle step like I just wrote down, that's totally fine. If you said, well, 4x squared times x is 4x to the third, perfect. And then 4x squared times negative 4 is negative 16x squared. That works for me. Either way, I've got 4 times 1 is 4, x squared times x to the first is x cubed, 4 times negative 4 is negative 16, and then x squared. Number 4, again, I've got a binomial, which means I have 2 terms, times a binomial with 2 terms. So I have to make sure that everything in the first parentheses, everything in the first polynomial goes to everything in the second polynomial. So I can go make my 2 arrows, or first times first is 2x times 3x. First, or my outsides, 2x times 1. And then my inside is 4 times 3x. And my 2 last pieces is 4 times 1. Again, if you didn't need to write that down, if you just saw, well, 2x times 3x is 6x squared, that's fine. 2x times 1 is 2x. 4 times 3x is 12x. And then 4 times 1 is just 4. I'm not done yet because I still have like terms. So I say 6x squared doesn't have anyone to add like terms with, but 2x and 12x does. Total, that's going to be 14x. And then plus 4 is my final answer. I do need to see your work, but if all I see is this step and this step, I will take it just fine. Notice that we are also having our x squared, then our x, then our 4, so we're writing our powers in descending order. Okay, number 5 is when it starts to look a little more complicated, maybe something that you haven't seen before, but it's the same concept. I want everything in this first parenthesis, the first polynomial, to multiply by everything in the second polynomial. So I'm going to say this x has to multiply by the 3x squared, by the negative 2x, and by the negative 4. So let's see what that looks like. X times 3x squared. Well, 1 times 3 is 3. X times x squared is x cubed. And then x times negative 2x. 1 times negative 2 is negative 2. X times x is x squared. And then 1x times negative 4 is negative 4x. I still have to multiply my negative 3 by everything. I'm going to go negative 3 times times positive 3x squared. That's negative 9x squared. I'm actually going to line that up right under my x squareds so that I can add straight down. So negative 9x squared, and then negative 3 times negative 2x. Negative 3 times negative 2 is positive 6x. Again, I lined it up right under the x. And then negative 3 times negative 4. Negative times a negative is positive. Positive 12. And then I'm going to combine my like terms. I got 3x cubed. Negative 2 plus negative 9 is negative 11, x squared. Negative 4 plus 6 is 2x, and then plus 12. So I think that these markings help me because then I know that I've really checked off all the pieces. You can also say if I have 2 terms in my first polynomial and 3 in my second, if I multiply those together, I should have 6 terms total. So I had 1, 2, 3, 4, 5, 6. So I'm sure that I've done everything that I need to. And number 6 looks super complicated, so let's make it a little more simple. If I have x minus 1 times x plus 4 times x plus 3, that could get complicated quickly, but I do already know how to multiply these two together. Because let's think about it. If I multiply 2 times 3 times 4, how I multiply that together is I say, well, 2 times 3 is 6, and then times 4 is 24. I multiply 2 first, and then I can multiply the last one. Or I might say, alternatively, 2 times 3 times 4. I could say this is 2 times 12, which is also 24. So it doesn't matter which 2 I multiply together first. I just want to multiply 2 of them, and then multiply that third one in. Okay, so let's first of all attack this x minus 1 times x plus 4. X times x is going to be x squared. X times 4 is 4x. Negative 1 times x is negative 1x. And negative 1 times 4 is negative 4. I know that I still have my x plus 3, so I'm going to leave that in there. And let's do some combining. So I've got x squared. And then 4x minus 1x is 3x minus 4 times x plus 3. Now this looks like something we just did on number 5. So I'll use a different color. I do my x squared times x is x to the third. X squared times 3 is 3x squared. If I keep going, my 3x times x, is 3x squared, so I'm going to line it right up under the x squared. 3x times 3 is 9x. And then I still have one more piece. I've got that negative 4. So negative 4 times x is negative 4x. Again, I'm going to line it up right under the x. And then negative 4 times 3 is negative 12. So I can combine all of this together. X cubed doesn't have anything to add with, so I just have x cubed. 3x squared plus 3x squared is 6x squared. 9x plus negative 4x is 5x. And then negative 12. So now I've taken care of my x cubes, my x squareds, my x's, and my constant. This is the end of just the regular multiplication, so I'm going to pause this video. There is one more page of notes that you can watch on special products, so you can take a break, do what you need to do, and then come back and watch the second video.